So welcome to the introduction to volumes or solids of revolution. Okay, so basically what we're going to do is we're just going to do a quick intro and then we're going to get straight into the three main types of questions that are asked. So here we have a nice little picture here, and what we're going to do is here is a disk of width dx, and this here is y equals f of x, and basically you can see what we have done is we've got y equals f of x here, and we have rotated it 2 pi around the x-axis, and what we want to do is we want to find the volume of the solid generated. Well, if we look at one particular disk like this white disk here, well, basically the air volume of that is equal, well, here, this bit here is y, so the area is pi times y squared, and then times the height, which is dx. So basically the volume of this disk here, the white disk, is pi y squared dx, or pi f of x squared dx. A lot of people use f of x squared instead of y. And then if we want to find the volume between a point, for example, A and B, then all we have to do is we have to sum up all of the volumes of the disks, i.e. we need to integrate between A and B, or again integrate between A and B, and that gives us here, this integration here is the volume of the solid of revolution. Now, just before we carry on, if we were to do it around the y-axis, and a lot of people get confused about this, but there's really no need to. So here is a function, let's now say it's x equals f of y, and we are rotating it around the y-axis. We would rotate it around like that, and here would be the volume, and basically that integral, would be the integral between a and b of pi x squared dy. Basically all we're doing is we're flipping all of the x's and the y's. Now, if that doesn't make a lot of sense, well, let's get straight into the questions anyway. There's three questions. We're going to do all three types. So let's go on that. Okay, so basically what we're going to do is, first of all, I'm just going to remind people what the volume of a cone is. So if you have a cone like this, and you'll see why in a minute. So we have a cone like this, which is height h and radius r, then the volume of the cone is pi r squared h over 3. Okay, and we're going to use that in all three of the questions. So let's get into question number 1 here. This is the most common type of question. Okay, find the volume of the solid formed when the graph of the function y equals x over 3 for x between 0 and 6 is revolved through 2 pi about the x-axis. Okay, what are they going on about? Well, basically, let's have a look at our xy axis here. So here is the x and here is the y. Y equals x over 3 is basically that. That is the y equals x over 3. So that point there, and we want to do it between 0 and 6. So this point here is 0, 0, and this is x equals 6. So this point here is basically 6, 2. And what we're going to do is we are going to rotate it around the x-axis, and that is going to produce the cone, which is that, and we have to find the volume. Now, as we know that it's a cone, we can actually work out what its volume is without bothering to do the volumes of revolution, because we know that h, i.e. the height of the cone, is 6, and we know that r, the radius of the cone, is 2. So we actually know that the volume of this cone is equal to, just using the formula of the volume of a cone that we did just a minute ago, is equal to pi times 2 squared times 6 over 3, which equals 8 pi. So we know our answer is going to be 8 pi, but let's use our volume of revolution formula. Okay, so what we're going to do is we're going to say that the volume is equal to the integral between a and b of pi y squared dx. Okay, well, we know that y is equal to x over 3, and we know that a and b, it's going to go from 0 to 6 because it tells us that in the question. So all we need to do is plonk all of that in. So that is the integral between 0 and 6 of pi times y squared. Well, y is x over 3, so that's x over 3 squared dx. This will give us our volume, which equals pi, taking pi out of the integration because it's a constant, pi over 9 the integral between 0 and 6 of x squared dx, which equals pi over 9 x cubed over 3 between 0 and 6, which equals 6 cubed pi over 9 times 3, which equals, we'll do it in my head, that's 2 cubed times 3 cubed over 9 times 3 pi, which equals 2 cubed pi, which is 8 pi. So we have found that the answer using our volume of revolution formula is 8 pi, and of course using the volume of a cone it is also 8 pi. Now this is the most standard type of question that you get given. Basically you revolve it around the x-axis, and by the way it doesn't really matter. I've done an easy example here, y equals x over 3, but if it was y equals x squared it would be like that, and we would have revolved it around. It's no different, it's almost identical, but instead of having y equals x over 3 we would have y equals x squared, and when we square it it'd be x to the 4, but the integration wouldn't be any more difficult. Okay, so now we're going to do a very slightly different question. This is question type number 2, almost an identical question, but instead of revolving it around the x-axis we're going to revolve it around the y-axis. Okay, so let's have a look again. Here is our xy plane here, here's our x, and here is our y, and again here is the line y equals x over 3. So this again is the point 6,2, exactly the same, and this is the point 0, 0. But this time we're revolving it around the y-axis. So let's have a look. So basically, it's going to take up all the space here, we are going to revolve it around here like that, and we still get a cone, but this time the cone is going to have a height of 2 and it's going to have a radius of 6. So again, we can, before we use our volume of revolution, we can actually work out what the volume of this cone would be, and the volume would be equal to what would the volume of the cone be equal to? Would it be equal to pi, because we got h equals 2 and we got r equals 6, so the volume would be pi times 6 squared times 2 over 3, which is 24 pi. So we know that the answer is going to be 24 pi. Okay, so now let's do it. Oh, and by the way, just one other thing which is very important. This illustrates a very important point. When we rotated our line around the x-axis and got cone A, if you remember at question 1, the volume of that was 8 pi. Now we're rotating exactly the same thing but around the y-axis. We're getting a completely different answer, and that's a really important point, because there's absolutely no reason why the rotation around the x and the rotation around the y-axis should be the same at all. In fact, they're not, unless it's a symmetrical function. Okay, so we found that the volume rotating around the y-axis is 24 pi. Okay, so now what we're going to do is we're going to use our formula that the volume rotating around the y is between a and b of pi x squared dy this time. Remember, we just flipped the x and flipped the y. So what we need to do first of all is we need to rewrite our function y equals x over 3 in terms of x equals y, function of y. Well, that's quite easy. Well, x is just equal to 3y, so we've done that. And secondly, we just have to remember that a and b are now moving up the y-axis, so that will go between 0 and 2. And apart from that, it's just child's play. So between 0 and 2, pi times by 3y squared dy. Okay, now we're integrating with respect to y, so that equals, we can take the 9 pi out, the integral between 0 and 2 of y squared dy, which is 9 pi times y cubed over 3 between, 0 and 2, and that equals 9 pi times by 8 over 3, which equals 24 pi. So we get the same answer, obviously, whether we just work out the volume of the cone using the volume of the cone formula, or whether we use our volume of revolution. We get the same answer. That's the second type of question, and as long as you're just careful that you remember that everything is flipped here, between A and B are both on the y-axis, not on the x. The x, we need to get the function as x is a function of y, and then we integrate with respect to dy. These are relatively similar questions to question number 1. Now question number 3 is the third kind. Okay. So basically here what we need to do is we need to find the volume of the solid form when the region between y equals x and y equals 2x for x equals 0 to 6 is revolved through 2 pi. This is the third type of question, so let's try and draw this, and I'm probably not going to draw it very well, but let's have a go anyway. Right, so basically here is our x y plane. Okay, so let's draw the line y equals x between 0 and 6. So this point here is 6, 6, and obviously this is the origin. And the line y equals 2x, I'm going to draw up here like that, and apologies if it's not particularly to scale. So this is going to be the point 6, 12. So here we have y equals 2x, and here we have y equals x. Okay, now what we're going to do is we're going to rotate around the x-axis. So there is the y equals x rotated around the x-axis, and then we've got y equals 2x rotated around the x-axis. This isn't going to fit on, but you get the point. So here is y equals 2x. I have to go back up again. So here is y equals 2x rotated around. We've got two cones, and basically the cone that well, it's not a cone, sorry, but the volume of revolution that we want is this bit, the bit that is between the two, between y equals x and y equals 2x, rotated around. And the way to find that is to find the volume of the big cone and then take away the volume of the little cone. So we'll do that first just by using the formula for the volume of a cone, and then we will do it using the volume of integration method. Okay, so for the large cone, we have that the radius is clearly equal to 12 and the height is equal to 6. So the volume of the large cone is equal to pi times 12 squared times 6 over 3, which is 288 pi. And then for the small cone, we have the volume of the small cone. Well, we have that r now is 6 and h is still 6. So the volume of the small cone is pi times 6 squared times 6 over 3, which is 72 pi. And so therefore the volume we should find of the region which is enclosed between the two of them rotated around should be one take away the other one. So that the answer to we should find the answer is equal to 216 pi, which is 288 pi take away 72 pi. Okay, now the formula is basically very similar to the formulae that we've just looked at. The volume of a region is equal to the integral between a and b of pi times by y1 squared, where y1, and I'll come back to that in a sec, minus pi times by y2 squared dx, where y1 is the larger of the y's. So in this case, as clearly y equals 2x is larger than y equals x, i.e. it's further away from the x-axis, then we use y1 will be 2x and y2 will be x. And basically all we do now is we just integrate that pretty much the same way that we did in question 1. So we have the integral between 0 and 6 of pi times 2x squared, because y1 is y equals 2x, minus pi times x squared, that's the y equals x, dx, and that equals, we can take the pi out, that equals pi, the integral between 0 and 6 of 4x squared minus x squared dx, which equals 3 pi, the integral between 0 and 6 of x squared dx, and that equals 3 pi times x cubed over 3 between 0 and 6, which equals pi times 6 cubed minus 0, which is 216 pi, which is exactly the same as the answer that we got by doing it manually using the two volumes. Okay, now just one other thing. Even though we used straight lines as our functions, it really isn't much more complicated if we weren't to use straight lines. So let's say, for example, that we had one of the common ones is y equals x squared here and y equals x here, and they want you to rotate the region enclosed between these two. Obviously they cross at point 1, so normally it's between 0 and 1, and what they want is they want to rotate this region here around. And all you do, well, clearly on this one, the y1, i.e. the larger y, is y equals x, and the smaller y is y equals x squared. This is y equals x squared. And all you do is use exactly the same formula, exactly the same integration, and that will get you the right answer. Okay, anyway, so that's the end of this introduction. In the rest of the podcast, we're going to be doing some more examples, real-life examples from exams. Hope you found this useful. If you have, please like this video and subscribe to the Gresty Academy YouTube channel, and look forward to more videos in this podcast. Thank you.